Thank you for coming to Spotify tonight, and I hope you enjoyed the beer and pizza. I know how much geeks like or hate pizza. So, just a quick overview. I'm not going to bore you too much with Spotify stats, but one thing just to kind of put out there is that we're pretty much on all different native applications, web, iOS, Android, Windows, Mac. And we're a service-oriented architecture, so we have on our back end, we have over 50. It's hard to get a nail down an exact number, but it's probably closer to 60 to 80 different services throughout. We're primarily using Cassandra, though there's different elements of our system. We're using Postgres and Tokyo Cabinet and a couple different other things. We have about 7,000 servers in production right now. That's growing quite rapidly. I believe it was closer to 6,000 6 months ago when I joined. And we about have 500 engineers worldwide. So one of the challenges that we had is how do we package our software? We primarily are Debian shop, so we use Debian packages, which works great. But how do you solve that for Python versus Java versus all the different technologies that we're using? So what have we been doing? So prior to when I started, we were actually using Debian stable packages, which works great. They're awesome, except for one thing. It's not really keeping up with the state-of-the-art Python development. They're always delayed, they're always behind, and there's good reason for that. But sometimes you need the latest and greatest. Sometimes you need that updated package. So we started backporting those libraries as needed into our libraries. So we have our own Debian package repository. And all the dependencies are therefore defined in those packages. So our application will list every single dependency they need, and that becomes a pain in the ass when you start developing software on our local boxes, which, as you can see, is a Macintosh. This is the quick chart that I tried to conceptualize what we were doing. So as you can see, we've got our Debian packages using Aptitude to get to our servers. We have our code coming through Git, going up to our TeamCity build servers. We also have this nasty little thing from GitHub backporting code that's already available out in Python, so why are we repackaging code was a question. And then our config's coming through Puppet. So we're doing some good things, but we're doing some kind of extra work as well. So what's wrong with that? One of the things is, as I mentioned, Debian stable doesn't include the latest and greatest. While they try to keep up to date as quickly as possible, things lag, and sometimes you need that bug fixed. It requires backporting. Backporting is a hugely manual process of copying code from the GitHub repo or whatever services that they're using, creating builds in our services, creating Debian packages for those, and then trying to override those in our requirements. And it doesn't use normal Python packaging. So it's really annoying as a Python developer to sit there and use pip or easy install, if you will, and then have to transfer over to some other system when we're actually on our servers. We primarily use Mac as our development platform, but we also have people using Linux, we have people using Windows, and so it's really annoying to have to be able to find dependencies in multiple places so that things can work. One of the things that happened is we've concentrated on making our live systems really great, and we have our great dependencies in our Debian packages, but then ramping up a new engineer is really difficult because we have to say, look at the Debian requirements package or requirements file and just start installing manually on your system and hope you get the right version, which is not really good. The other option that I've done previously is you have your setup PY file or your requirements text file, you list all your dependencies there, then you manually duplicate those into your Debian package or have some hacky script that converts between the two. The other big thing is rollback is not consistent. So you can roll back your application pretty well because it's just a Debian package, but what happens if it updated a dependency? Well, you can snapshot if you're using images or if you're using virtual machines. That works great. But what happens when you just want to roll back your application but not everything else that might have changed? So right now, the way you'd have to do that is look at your deployment history, start rolling back, and that takes time. The other big thing that kind of goes under the radar but comes back to haunt you on occasion is that what you're testing on your server, this gets to the heart of, well, it worked on my machine, which I know all of us in this room have used more times than we care to admit. And annoys all the QA people if there's anybody out there. But what happens is we test on our machine with our environment, with our setup file. Maybe we deploy it to a continuous integration environment where it's testing with its own idea of what the world looks like. And then we deploy it to our server, which has maybe a different look at what we're looking at. So the idea here is let's package up the thing that actually is our application, which is our code, all of our dependency code, and see if we can figure out a way to solve that. The other thing that we run into is if you're installing packages directly through Debian, it's installed into the system Python, which means that if you upgrade a dependency, it upgrades it for everybody. If you're running multiple services, multiple code bases, you now have to coordinate between teams. And then from a previous slide, we have about 500 engineers. It's pretty difficult to get 500 engineers to ever agree on anything. Even in the Swedish culture where consensus is king, it's really difficult to get that many people on board. So there must be, we decided a while back that there must be a better way to package Python code. It works better in other languages, it works better on more systems. So what can we do? So we wanted to avoid duplication of effort. We wanted to increase the stability and the repeatability so that if we set up a new server, it gets set up correctly. We wanted to offer an easy rollback so that if we have a release that's bad, we can very quickly and easily roll that back. And we wanted it to be able to scale. So as you can imagine, when you have 1 or 2 services, your dependency list is fairly small, maybe a dozen. You have 50, 60, 80 services, you're all of a sudden, we have over 100 different, probably closer to 200 or 300 different packages that we're backporting that we have to keep and we have to maintain and we have to keep going with. So what do we do now? So one of the things some of my colleagues in Stockholm is they created something called DH Virtualenv. So the DH is for Debian Helper, for those who don't know, and Virtualenv we probably all know because we probably all use it on our systems every day. So what does it do? At first it registers itself as a Debian Helper, and what a Debian Helper is it goes through and says, and is a process that happens whenever we do a build. So just like other ones that are shipped, there's a Python Debian Helper that will, in general, try to help you deploy Python code. We just register ourselves in there. We actually replace all of the other Python Debian helpers because we don't want any conflicts. What it does is it takes your requirements.txt file and bundles all of those things into a virtual environment. It builds that virtual environment and then it bundles that up. So what you're actually deploying is that virtual environment, which is the exact same thing that you tested on your server. Hopefully it's the exact same thing that you tested on your CI server for unit testing, and it's the exact same thing that you're going to deploy. So there's that repeatability. It deploys it currently into the user share Python, although that's configurable and pretty easily changed in the code. One caveat is it still requires that your native code be compiled and included with Debian because pip has its limitations. It's not going to be able to install a pre-compiled version onto your server and compile it there. So what happens there is, since our build servers may not be the exact same operating system architecture as our deployment system, we don't want to deploy any of those native code because we might have conflicts with the operating system. And what do you do? How do you do it? Well, you just include the following in your Debian rules and you're done. Sounds easy, right? So going back to our previous picture, our new deployment process doesn't look that much simpler. But one thing to notice is that this area here is a lot easier because we're pulling from PyPy. We no longer have that backporting going into our Git repository. We no longer have to keep that up, and that entire manual process is completely removed. We now rely on the maintainers of the libraries to decide when and if we should be updating and when and what's available. And the reason there's a line into the Team City is that's all being pulled into a virtual environment on our build servers. So first of all, it worked, which was kind of eye-opening. We have not converted all of our Python applications over to this yet. We're still in the process of that. But we have an example where we have an application using Sentry for log processing. And one of the things that we had to do is, all we had to do this so that it works on your development system and it works on our servers is include our dependencies in the requirements.txt, which we're all familiar with. For those of you using Debian, you're probably familiar with defining dependencies in Debian. So here, instead of having a large list with everything, we just have a couple of things where we require Python, require virtual environment, a couple of different other packages to support some of the things that Sentry needs for SSL and logins. And then inside our rules file, we just specify, this is the only required line, which says use the Debian Helper for Virtualenv. Here we're actually overriding where we're grabbing packages from. So in this case, we're grabbing it from our local mirror. I hid the host name. But this is just our local mirror PyPy as opposed to defaulting to PyPy. Previously, for a few people in the audience who knew me in a previous life, I worked at Amplify, and we did a very similar thing, but we used RPMs there because we were using CentOS and Red Hat systems. And we did a very similar thing where we built the package, we installed it, we installed all of our dependencies, and then we just packaged it with this relocatable. So the authors of Virtualenv are probably going to kill me for this, because if you read the documentation, it's very clear that relocatable is an experimental tag that may be removed in future versions. But it works. And what it does is it just removes all your absolute paths and replaces them with relative paths. So one of the things is, what does this give us? First, we're no longer stuck on stable. So we weren't stuck on stable before, but for those of you that don't want to go through the process of backporting, you might be. We no longer have to do that manual process of backporting. We have code isolation. So one of the other things that previously I talked about was the fact that if we have multiple things running on the same server, we either have to come to an agreement about an upgrade or we don't upgrade. And odds are we don't upgrade. And we probably all have code out there that has a 3-year-old dependency that is buggy as hell and we just haven't updated. So here now, each application is using its own virtual environment, and therefore we can upgrade just as we would on our development machine. We also have a single package rollback, because outside of those native library dependencies, everything's within our package, including whatever packages we're using, whether that's the LDAP package, whether that's Django, or whether that's Flask, or whatever system that we're using. It's all in our code, it's all in our package, and all we have to do is roll back that one thing. Development and deployment systems are now the same. So the thing that I test on my server is as close as possible to the thing that I'm going to actually deploy to the server. The thing I run unit tests on in our CI environment is the exact same package that we're deploying. So it's great, but if you notice, we still have that one caveat, which is native applications or native libraries are still being deployed by Debian dependencies, which means that there's a deployment time dependency resolution, which is really, really terrible. There's ways to solve that, and we're starting to investigate those next. But to be honest, we're not 100% sure where we're going with that. One of the things we do at Spotify is to try to experiment with everything and figure out what works. One thing that is that DH Virtualenv, as of 2 days ago, is now on the Debian Unstable repositories. So still getting to that fact that we applied for inclusion, I believe, 3 or 4 months ago, and they're still fighting to get into that stable branch. Kind of makes a point for me. Still requires managing native dependencies locally, which is bad, because that's one more. Every time we do a deployment resolution, we're probably encouraging a problem. Because unless we're actually going to be hard coding in every single specific version number, which creates its own issues, what we're saying is, when I deploy in my CI environment, I'm going to test one thing. When I deploy in my production environment, even if it's hours later, I'm probably going to deploy a different version because something updated, something changed. We're also experimenting with containers. So there's some people working with us in Spotify where we're actually saying, okay, let's try to take this to the next level. Now that we have virtual environments for our Python code, we still have issues with Java. We still have issues with some of the C code and some of the other pieces of technology that we're using. Let's start deploying this stuff as containers. So we're actually bundling up those native library dependencies now and trying to deploy those using Docker. And stay tuned. I hope that we'll continue iterating on this. I hope we continue pushing forward on how to deploy this Python code, and that we can kind of refine it a little bit more. Just a little thanks to Yerke and Jim, who work out of our Stockholm office, who actually wrote most of this code and promoted it and wrote the blog post or the white paper down at the bottom. And so thanks to them for actually writing this and taking the time out of their day to make things a little bit more sane. And that's it. Questions? One in front.
I'm going to have to steal that from you.
Sorry.
PyPy is often behind GitHub. How do you deal with that?
In those cases where we actually need that kind of leading edge, we would probably still look at backporting, and actually we have our own PyPy server, both that we mirror PyPy, and we also have our own library or our own repository for our code. And most likely what we would do there is do kind of a manual step to do that. But if that continues to become a problem, that'll be the next challenge that we'll have to solve.
I'm going to do this with that.
Try to wear this. We'll just hold it up.
When you're deploying these packages on Virtualenv in production, are you seeing any significant differences in performance?
So far, I don't think this is working.
Bummer.
You can kind of hear. We haven't noticed anything. To be honest, one of the things that we've looked at, and I've done at a previous position, is we ran load testing against virtual environment versus native environment. And we noticed no difference. The reason being is kind of the way virtual environments is really working is it's just using pointers for the most part. So at the end of the day, following a pointer or having a direct link to the file isn't going to give you much difference. We, in terms of packaging and the actual build process, we took a little hit in the beginning because it takes a little longer to download all the packages and bundle them up than it would because you end up with a larger artifact than you do just bundling your code and doing a deployment resolution. But at the end of the day, we decided that this space was cheap and we'll just throw that out the window and go with reliability.
What channel?
You mentioned you had 7,000 servers. I assume that's in production, or is that globally with production dev?
Globally.
Um,
Production, sorry.
okay. You also mentioned that your build servers are different from your target servers. Is there some level of technical debt that has this situation, or is it just a question of you have regional differences that require you to have to perform local builds that just, because again, from my perspective, it just doesn't seem to make a lot of sense.
I'll wait for the mic. I feel like I should be doing a dance to you. That is a very good question, and it's technical debt. So most of we actually have very similar systems. So all of our systems are Debian. All of our systems are running very similar software. But because we're running our build systems here and we're running our production systems in different data centers around the world, there is a lag sometimes when we're updating packages. That lag should be pretty small, but also I think some of it is just literally tech debt from dependency management. Looking in the past, the more complex system you make, the more likely it is that people are going to take shortcuts. And so I think if you look at some of our systems, they're really clean, they're really modern, and they're really nailed down. If you look at some of our older systems where we were doing deployment time resolution, we were deploying the packages that made sense at that particular time in history. So you have slight differences between servers even, which is not good, which is something that we're cleaning up and trying to get a handle on. And you have problems with the fact that currently our build system has a certain set of dependencies installed so that it can actually do its tests outside of the ones where we're actually doing virtual environments. Before that, you were deploying a version of LDAP, for example, to our production services that everybody had to work against because we had one centralized build system. So as we move more to virtual environments in general, that will go away because we'll start having our isolation both on our CI environment as well as in our production service.
Sorry.
Oh, we got 2 mics? Oh, yeah. Is that unmuted? Okay. Is it unmuted now? That's. Oh. Now it's unmuted? Still muted. When you both at the same time, oh. Try that. 111 000.
Why don't you do that one and I'll work?
Anyway, how do you handle security updates since these are essentially statically compiled packages?
So it depends. If it's a security update that's part of the native dependencies, that would be something that we would take an inventory of our Debian packages and actually start updating those dependencies. If it's in the Python code, it's as simple as actually working with the squad. So the way we work here is pretty much independent teams that we try to treat as much as possible as mini startups so that we can actually get the agility at that level, and each team owns a certain portion of the functionality. So each team is actually entrusted to work with our security team to make sure that their applications are up to date. And if they aren't, and if there is a security hole, that they update either whether it's their code or whether it's a dependency, and update on an ongoing basis. Since all of the code is actually owned by a particular team, we can kind of have that kind of ownership to push those sorts of things forward, as well as new feature work, as well as new bug fixes and whatnot.
Good. Thanks, man.
So when a new version of stable comes out, do you have to rebuild all your Virtualenv packages for that new stable version?
So if we're talking about new stable version of the Debian packages, no, unless it's a new version of one of the core dependencies like the Virtualenv, for example, if there's an update to that, yes, we would do it there. If it's a dependency that's in the Python code, we would run our new build, and we're continuously running those builds as we change code, and on timers as well, and we would just get those updates as we go, depending on how we defined our dependency flags. If we're tied to a specific version, it becomes a manual process, which we all know probably doesn't happen. If it's a open-ended version and you have a really good CI environment, you have a really good continuous delivery model, then you're constantly testing against those newest versions of latest and greatest, and you're getting all those fixes, not for free, but for much cheaper than you would otherwise.
Cool. Awesome. Sweet. Thanks so much, Chris. Another little bit of a hand here.